4 decades of research in human beings, more than 700 controlled studies, populations from elite sprinters to elderly patients with Parkinson's disease, effect sizes for strength and power output that are among the largest reliably documented for any legal nutritional intervention, a safety record that includes supplementation in patients with pre-existing kidney disease without adverse renal outcomes. Creatine monohydrate is not the most proven supplement for building muscle because of a particularly aggressive marketing campaign. It is the most proven because it has been tested rigorously enough and repeatedly enough that the question has a clear answer. The specific mechanisms through which creatine supports muscle development are multiple and operate at different timescales. The phosphocreatine buffer is the fastest acting and most direct. During high-intensity effort, phosphocreatine donates its phosphate group to adenosine diphosphate, regenerating ATP and allowing maximal force production to continue for several seconds, beyond what ATP alone would sustain. More phosphocreatine available at the start of a set means more high-quality repetitions, more mechanical stimulus applied to the muscle fiber at the intensity required to drive adaptation. Volume is the primary driver of muscular hypertrophy. Total work performed at sufficient intensity, sets times repetitions times load, is the variable most consistently associated with muscle growth in resistance training research. Creatine supplementation allows more total volume per session by reducing the decline in power output within sets and supporting faster phosphocreatine resynthesis between sets. The training stimulus over weeks and months is meaningfully larger with creatine than without it, and that difference in accumulated training stimulus translates to greater muscular development over time. Beyond the acute energy system effects, creatine has documented anabolic signaling properties. The AMPK pathway, which senses the AMP to ATP ratio and activates energy conservation responses when cellular energy status is low, is less activated under creatine supplementation because energy status is better maintained. AMPK activation during training inhibits mTOR-mediated protein synthesis. By reducing AMPK activation through better energy maintenance, creatine creates a more permissive environment for mTOR-driven muscle protein synthesis in the post-exercise period. Satellite cell activation, the process by which muscle stem cells are recruited to support muscle fiber repair and growth, has been shown to be enhanced by creatine supplementation in research using muscle biopsy techniques. Satellite cells are essential for the hypertrophic response to training. They provide nuclei to growing muscle fibers and support the increased protein synthesis capacity that muscle growth requires. The mechanism linking creatine to satellite cell activation is not fully characterized, but is consistent with creatine's broader effects on cellular energy status and anabolic signaling. Water retention is frequently discussed as a caveat to creatine's muscle-building effects. The initial rapid weight gain from creatine, typically 1 to 2 kilograms in the first week of loading, is predominantly intramuscular water. This water retention accompanies the osmotic effect of increased intracellular creatine concentration. Critically, this intramuscular water is not cosmetically unfavorable like subcutaneous water. It contributes to the fuller, denser appearance of creatine-supplemented muscle and may itself support the cellular environment for protein synthesis. Long-term lean mass gains from creatine EA, assessed after weeks to months of supplementation, reflect genuine muscle tissue accretion beyond the initial water component. The proven status of creatine in muscle building is not contingent on any single mechanism. It is the result of consistently demonstrated effects across multiple independent mechanisms, replicated in study populations ranging from teenage athletes to 60-year-olds returning to resistance training. The evidence hierarchy for muscle supplementation reflects creatine's unusual position. Most supplement categories have evidence from small studies, short durations, or methodologically limited trials. Creatine has evidence from large sample, long duration, randomized controlled trials with objective outcome measures. Muscle biopsy, DEXA scan, strength testing under standardized conditions, and in some cases magnetic resonance spectroscopy for phosphocreatine quantification The methodological quality of creatine research is substantially above the supplement average. 4 decades of research across populations and conditions have produced the most thoroughly stress-tested safety and efficacy profile in sports nutrition. The word proven is used loosely in supplement marketing. In creatine's case, it is literal.